So first, identifying all of these. A couple of them are the same as we've dealt with before. Okay, R is still the rate. T is time. That has not changed. What is different now, though, is whenever we've had the basic, just a times b to the power of x, our a was our initial. Whenever you're dealing with this, a is actually the final. That is because if you ever take kind of a finance class or whatever, this is kind of just the basic of the basic. That's the formula that whatever these notes we typed, and I don't think they've changed the variables in it, but that's what those are. Okay, so we wanted to kind of keep that the same. P is going to be the initial amount. All right, and what that actually stands for is the principal. N is what is something that is going to be completely new. Make sure that you're writing small here, and it is the number of times compounded in 1 year. Okay. So let's talk about that. Now, does anybody know what compounded means? Okay, it's just kind of combining two things together. All right, now in context of this unit, to give you just a Mickey Mouse example, if I have $100 in a savings account, and let's say it has 7% interest, whenever it's compounded, it takes 7% of the current balance, which is 100, which would be $7, and it adds that onto the balance. So it combines those two, okay, the current balance and the interest that is accrued from it, depending on the balance and the rate, and then they add them together. So the new balance would be 107, okay, which is good if it's a savings account and not so good if it's, say, a credit card. All right, now, whenever you get into those problems, it's not going to say, okay, hey, it's going to be compounded 8 times a year. It's going to be something like those next 4 words. Okay, compounded daily, monthly, weekly, whatever. And so you have to think, okay, if it's monthly, if something happens monthly, how many times in 1 year is that going to happen? 12. So my end value would be 12. If it's semi-annually, then it would be something happens semi-annually. How many times a year does that happen? Do what? Twice. Semi means half. So each half year. Annually would be what? Once. Quarterly. 4. Okay. Garrett, will you read that paragraph, please?
The more often interest is compounded, the greater the amount of money accumulated. Hypothetically, interest can be computed and added to the balance of the account every instant. This is called continuous compounding and is defined by the formula A equals P RT. There's an R times E.
There. Yeah.
Where B is a constant approximately equal to 2.718. This constant is often used in applications involving exponential growth. The exponential function most commonly found in nature is based on an irrational number. The natural base e, it has properties that are similar to pi. Non-repeating decimal doesn't end. The number denoted by the letter e in honor of the mathematician who discovered it,
Leonard?
Leonard? That's how you spell Leonard. It's a different kind of
Definitely not Leonhard. Leonard Euler. Okay, so you've got this variable e that we kind of need to talk about. It is and all I really want you to think of it right now is just, it's exactly like pi. It has a number assigned to it. You've just probably never heard about it. Okay, but it's exactly like pi. It's got a repeating decimal that's already assigned to it. So whenever you're going through a problem, don't look for a value to plug in for e. It already has a value assigned to it. Okay, you need to know how to put that in the calculator, and all that is second division. Okay, if you hit that in the calculator, a little e pops up, and if you were to hit enter with just e, it's going to give you that 2.718 number. Alright, so whenever you're dealing with one of those problems, you'll need to make sure to put that in. Do not put 2.718. I want you to use second division. Put in e. Alright. So, going to kind of looking at this box. In a nutshell, these are the three formulas that we're going to deal with in this unit. Now, the formula chart that I just gave you, it's very detailed and it explains every little thing, but these are the three. It has a couple different variations of them, but these are the three that we're going to use. You need to know which one to use and when. So, if the problem says that it is compounded continuously, you're going to use that one. Okay, so that's kind of the first one that I would check for. Does it say compounded continuously? If it does, then you'll use that one. You'll hear me refer to that one as APERT. Okay, if you just kind of pronounce it, looks like it would be pronounced APERT. If it says that it is compounded any other way, all right, annually, monthly, weekly, daily, whatever, you're going to use this one. This is probably the one that you'll use the most often between those two. Okay, and then if it does not have the word compounded at all, you'll use just the general growth and decay. You do not have to memorize those, no. Okay. For the most part, these two right here, they'll be talking about money in some way. Probably about a savings account, bank account, a loan, a credit card, something. All right, for the general growth and decay, it can talk about money, but if it doesn't say compound, then, that's the one you'll use. It can still talk about money, that's fine, but if it does not say compound, if it says compound, you will use one of these two, continuously, any other way. Okay, so it's kind of, you got to be able to figure out which one of those you will use on each problem. So, Isaac, will you read number 1 for me? Okay, so Chance, which formula am I going to use?
Continuously compounded.
And what tells me that?
It says compounded.
It says compounded continuously. Okay, should be pretty cut and dry. Especially early on, what I would like for you to do is, because there are a lot of variables that you have to identify the values for, off to the side, kind of make a little key, and then you'll just plug those into the formula. Okay, so I'm looking for the final amount. And Ellie, what is the initial amount put into the account on this one?
2,500.
Okay. Aaron, what is the rate as a decimal? That'd be 50%. 0.05. The rate would need to be 0.05. And then Zach, how many years are we talking about on this problem? 5 years. So all I'm going to do is just take those values and plug them into the formula and see what the calculator spits out. Okay, so practice putting this in, because you need to practice using the variable e. You also need to make sure to, whenever we get to the other problems, that you know how to put that one in, just the regular compound interest. should get, if you do this one, you should get 3,210.06. Okay, did anybody not get that? Alright, the next problem is kind of a physics-y or maybe chemistry-esque problem, and I didn't really like either one of those classes, so we're going to go to 3. Trey, will you read number 3 for me?
$800 is deposited in an account that pays 9% annual interest, compounded annually. Find the balance after 2 years.
Okay, so on this one, Gracie, what formula am I going to use? Does it say compounded?
Yeah,
How?
annually.
So which formula?
Compound growth.
Compound growth. Okay, so I need to identify all of these variables. And Marshall, how much was put into the account originally? Bree, what is the rate as a decimal?
0.09.
Chance, what is my end value if it's compounded annually? 1. And then we're talking about 4 years. So this is what that equation would look like. And you especially need to make sure that you can put something like this into the calculator. On this, make sure that you get $1,129.27. Since we are talking about money, make sure that you are rounding to 2 decimal places. If you got that, go ahead and attempt the next one on the back. If you did not get that and you're not for sure what you did wrong, let me know. I'll come around and look at your calculator. It's probably something as small as you accidentally put 0.9 instead of 0.09, or you accidentally put 8,000 instead of 800. So on number 4, this is the equation that you should have gotten. And on that one, you should have gotten $4,081.54. All right, Lily, will you read number 5 for me, please?
How much do you deposit in an account that pays 6.25% interest, compounded annually, to have a balance of $700 after 2 years?
All right, we're going to tell you what's different about this problem than all the other problems we've done so far. Nope. Yes?
There's no initial amount.
Okay, it doesn't tell you the initial amount. So you got somebody who, after 2 years, wants the account to have $700 in it, so they want to know how much to put in initially. Most of these problems, you're either going to be, most of the problems, you're going to be given all the variables except for A or P, and you'll be asked to find the other. Okay, a lot of times you're just asked to find the final amount, and those are pretty simple. Those are the ones that we've done so far. So on this one, again, we are given the final amount, which is 700. Zach, how many years are we talking about? How many? 2. Olivia, what is my end value?
1.
And Ellie, what is my rate as a decimal?
0.0625.
I would then plug it in, so 700 equals the initial times 1 plus 0.0625 over 1 to the power of 2 times 1. Okay, so now how do I solve for P? What do you tell me? Joe?
You have to get P by itself.
Okay, what does that entail? How to get P by itself?
You have to start by getting rid of the exponent.
Not necessarily. Morgan?
You have to divide 700
Divide 700 by what?
by 1 plus 0.0625. You put 700 over all
Okay. So don't, it looks a lot more complicated than it is. Okay? This is P times something. So I can just divide by all of this, and that will tell me what it equals. Now don't start putting that in your calculator. I don't want to show you something on this. So if I have P equals 700 divided by all of the 1 plus stuff. Okay. So I can do that, but if it is something that is compounded annually, that means you're dividing by 1. So if you're putting this in the calculator, please stop and look up here. I'm going to try to make your life a little bit easier on these problems. If it's compounded annually, that means you're dividing by 1 and you're multiplying by 1. So you can simplify it a little bit so it's not as, there's less chance for you to make a mistake plugging it in. What is 0.0625 divided by 1? 0.0625. What is 1 plus 0.0625? 1.0625. What is 2 times 1? Okay, all that was pretty easy. And now I'm just doing 700 divided by this instead of all that. Alright, so go ahead and plug that in. You can do it either way you want. I would probably do it just kind of the second way. And whenever you do that, make sure that you get $620.07. Alright. Isaac, will you read number 6 for me, please?
You have inherited an old ring that had appraised value of $2,400 in 1960. It is now 2004 and the appraised value of the ring has increased by approximately 6% each year. What is the value now?
So, Bree, what formula am I going to use on this problem?
the exponential function.
Okay, so just the general basic one. So, why would I use that? Because it doesn't say compounded anywhere. So, if I can choose to just do the 8 times b to the power of x, that's what I'm going to do, because it's the simplest one. So, Joe, what is the initial value of the ring?
2,400.
Okay. Marshall, is it going to be 1 plus or 1 minus? 1 plus, because it's increasing. 6% is a decimal, is 0.06. So 1 plus 0.06 is 1.06. And how many years is it between 1960 and 2004? 44. Maybe you plug that in. Hopefully you're pretty acclimated to putting in something like that already. You should get $31,165.16. If you get that, then I want you to go on and attempt 7, 8, and 9. I'll be putting up the answers to those for you to make sure that you did it correctly. So on those, we're just going to look at it, identify if it's growth or decay, and then also identify by what percentage. Okay, so Andy, number 10, is that growth or decay? Is 2 above 1 or below 1? By what percentage? Okay. Ryan, is 11 growth or decay?
Okay.
By what percentage?
60%? No. 80.
80%. 12. Zach, is that growth or decay?
Growth.
By what percentage?
0.05.
Okay, so 0.05 is a decimal. That's the decimal.
5%.
So 5%. And Gracie, 13 is growth or decay? By what percentage? Don't feel silly if you got a really big number.
1,000.
Not 1,000,
900.
900%. Okay. Raise your hand if you're confused as to how we're getting those percentages. Okay. All it is it's the percentage. To get the percentage, it's always the difference between the B value and 1. Okay, so if I'm 13, my B value is 10. 10 minus 1 is 9. That's 900%. On 11, 1/5 is 0.2. So 1 minus 0.2 is 0.8, which is 80%. Okay. 10, 2 minus 1 is 1. That's 100%. 12, 1.05 minus 1 is 0.05, which is 5%. Okay, so it's always the difference between the B value and 1 to get to whatever the percentage increase or percentage decrease to get to that percentage, whether it's increase or decrease.